Okay, let me share the screen. Okay, so guys, you have a very important part in the report that you have to submit as soon as possible, the transportation part. What you're gonna do is basically you have to do a design for a road. I'm gonna give you 2 points. So if I go to the given, this given will be provided to you. Okay, you will have a surface, actually a AutoCAD file. It contains a certain surface where you have to design the road from point X to point Y. So I'm gonna give you 2 points. You have to design the road between these points. This is the given. The design speed is 70 km per hour. You will have 2 lanes. The minimum horizontal radius will be 200 meters, and the maximum minimum slope 7 to 0.5%. So we're gonna use AutoCAD Civil 3D. From AutoCAD Civil 3D, we're gonna draw the alignment, the surface profile, the assembly, corridor, and cross-section each 300 meters. What you're gonna do is the following: 1, draw the figures, and then you have to report all the data by exporting reports from AutoCAD Civil 3D. And in this session, I'm gonna start with the alignment and surface profile. I'm gonna give you a short example. You will do the same, but depending on what you learned in transportation. I'm talking about the horizontal curve, vertical curve, the restrictions, the K values, and so on. So let me just check. I have only now the students. I have, let me see. So I have only Gabi, Mirfana, and Ashraf. Okay. So let's go to the software.
دكتور
Yes.
هو اليوم لانه عندنا هلا اكزام هلا بعد شي نص ساعه.
Okay. Okay. So
وانا
I'm gonna
هلا
record the sessions. No worries. I'm gonna record it. It is recorded, and they can watch it later. It's not a problem. I understand. Just I'm checking.
Okay, doctor. Thank you.
Guys, this is the map. I'm gonna give you the same map or same surface. In this map, we have a topographic. Actually, these are called contour lines. What does it mean? Contour line shows the elevation at each line. For example, here I have a green line going in this direction. It means all the points in this direction they have the same elevation. If you go to the next line, this contour line, that it has a different elevation, different value, maybe higher, maybe lower. I don't know, but it has a different value. So if I go in this direction, either I'm going upward or downward. What I know is that I'm changing the elevation. Why I'm saying that? Because guys, when you need to design the road, you have to choose the trajectory of the alignment along the contour lines, because otherwise you will have steep slopes. And this is a problem. Like, if you want to understand it more later on, once I finish the problem, you can draw an alignment in this direction, and then you will export and visualize the section. You will see that we have elevations, very steep elevations. So if I give you an example here, let's check the what is it? Okay, this line here. So I want to check the elevation. Add label. Let's show you the elevation, spot elevation. For instance, this point here, if I press on it, look, it is 65 meters. It means it is 65 meters above a certain level where I have the datum equals 0. Let's check the one next to it. Okay, for example, this one here. Look, 70. It means I'm going upwards 5 meters between each contour. Let me do the next one also. Maybe one here. Okay, so it is 80. It means going 5 downward. It means the slope is going upward. So if you draw the section, you will have 5 meter offsetting elevation. In the first session, we're going to draw the alignment. This is the first step. The alignment is basically the road, the longitudinal section of the road, as we learned in survey. The road starts at a point and it ends at another point. So let's suppose that we're going to give this short example. From this point here till that point here, I'm going to draw the alignment. To draw the alignment, we go to alignment section, creation of alignment. We're going to call the alignment X. Of course, it's a center line. This alignment, it is centered at the center line of the road, as we learned in surveying. So it is basically going through the center line. Automatically choose center line. The site, it's not important. This is the proposed. We are working in the proposed here, so we choose proposed. And then for the label of the alignment, you can choose all labels or major and minor only. It depends on the condition, but I prefer that we choose all labels. Now we have to specify the design criteria. Always, when we do a design for a road, we have to know the design speed. The design speed is given to you. So let's assume it is 60 km per hour. It means that once the software check the alignment, the requirements in terms of radius, the length of the horizontal curve, and so on, it should be done according to the criteria selected. So if you select the criteria here, you click on it, the system automatically will check it. In this case, now we're not going to go through it. We just need to draw the figure, so uncheck it. Now we want to draw the alignment. If you go to the alignment layout tool, we have tangent to tangent with curves, and curve and spiral settings. So if we have a curve, or actually we will, this is the radius. By default, the radius of the horizontal curve. It is minimum 200. It's given to you that I'm going to use minimum 200 from, if you check the project, the given in the project, it is around 200 minimum. You can go higher, but the minimum is 200. Now we go back and we try to draw the curve. I'm going to draw it randomly. I'm going to talk about how we draw it, because you should know from transportation how to lay out the alignment. But just to give you an example, we started at this point. Okay, we click on it. Now, look, I'm going to go in this direction with the contour lines, not opposite to the contour lines. Otherwise, everything here, I'm going to basically go upward with the elevation. I need to go with the elevation at the same level. Otherwise, as I said, we'll have a lot of area of cut. So let's assume this is my first point here. Okay, then I have, maybe I chose, this is the curve, the first curve. Then I choose the second curve here. Okay, here. Then I finish with my point here. Of course, this is a very small example. Your project will be from this point, let's say, till that point. So you have to go in a zigzag direction, trajectory, in order to catch this point. You cannot simply connect these 2 points. The software usually uses your own simulation we can have many simulations, and accordingly you will draw the alignment. Guys, we have this alignment is ready. Let's check what we have here as values. So this is the first point. It is written to us the design speed is 60 km per hour. It is written also the station. So we are going in increment of 20s, as you can see, 0, 20, 40, 60, until we reach the final station, 2 plus 30, 360. As a first, so for example, we can take a report for these later on, and you can add them to your report in the submission later on. Report manager, you click. Here we are working in the alignment, stations and curves. We press OK. The Civil 3D will save it as a PDF, or it depends. Let's save it now as a PDF. We call it AL alignment. Okay, it is saved. So look, it will export all the data of the alignment with the station, within XY coordinates. Also for the if you have a circular curve, of course here we have curves, the horizontal circular curve. What is the radius? What is the length of the curve? What is the midchord? All of these, and you had them also with me in surveying. For those who took surveying, remember these, the configurations of the horizontal curve. And your objective is to check these values if they are adequate or not according to the standard that you learned in the transportation or using the software. So it is not the final answer. For example, this road is just a trial, but it is not basically a correct way of doing the alignment. So now we have the data for each station. We go back now. We need to draw the vertical alignment. We simply, now we finish with this one here. We press escape. We go to profile, create surface profile. We need to visualize this alignment in a surface area where we have the vertical view is clear for us. We have to create the surface. We press create. Here we have the alignment X. Maybe we can have several alignments, but as you can see, I only drew the alignment with a name it X. Automatically, it starts at this station, at end of this station. We saw that. If we press add, so we have display profile. It is listed now. Draw profile. So this is the name of the alignment. This is profile view CD. We can give it just a name. Here we have many options for the style. Either you create your own style or you use one available by default in the library. You can use either Land Desktop profile view or profile view only. It is different. It will give you here some grid lines in the Y and X. You can try both at home and see what is fits your preference. We keep it Land Desktop profile. The station range is basically I want to see the elevation from the start to the end or at a specific range. So I can, for example, choose the station 100 until the, let's say, station 1 plus 374. Not necessary from the beginning till the end. It depends on you. But in this case, in your road, you have to show all the sections. Then the minimum and the maximum height, we keep it as it is. Profile display also. Data bands and the profile hatch later on. In the next example today, I'm going to show you how to mark the cut and fill area once we draw the vertical alignment. Okay. So let's press create profile view. It is now created. We select profile view origin where I want to place it. I'm going to place it here. So look what we have here. Guys, this is the vertical alignment. So if I'm standing on this road, look how the elevation is changing. So this is here. If you go downward, this is the first station. Remember, we started at 0 and then we go up to the last station here, where we have 2 plus 360. It means we are starting here and we are ending in this direction. Imagine you are visualizing this road here from the top. Let's say you are in a helicopter and looking down, you can see this view that I'm showing you now. But let's imagine also you are standing here and you want to observe this road as a side view. You will have this section. Okay, you can visualize the elevation. This is the existing condition. Yani the road as it is. We have it as it is without any interference. It is called the existing condition of the road. And of course, if I check it, look how the elevation is changing. It's not consistent, so it is not adequate. It means we need to create a new vertical alignment. Why? Because at the end we have cars. It is not adequate for passengers. If they want to go from A to Z, they want to use cars. It's not adequate. To do that, we simply press on this one here. We have something called here. We press okay. We press on this one here. Yes, press on. It's called profile creation tool. So now we will create a new elevation, a new road. We call the proposed design elevation, where we have the trajectory done according to the restrictions that we will assume. So press it. We call it, this is of course for alignment X. If you have several alignments later on, you can select the one that you are working with. Let's call this one design vertical alignment. Okay. The design criteria, either you press it automatically will check it, or you keep it as it is. But if you check it, it will check the K value of the vertical curve. Of course, this one here, it is the design. We don't check, we check the design. It's a design profile, a new profile. And well, that's it. We press OK. As we did, and we draw the alignment, now we have to draw the vertical curve. The same scenario, we have tangents only, tangent with curve settings. Automatically, I'm going to choose the tangent with curves. We will start at, let's say here, okay, at this point, and we will increase, let's say in this direction here. Okay, later on, you see here the curve now. I have the curve, this is the transition curve. We have, let's say, transition curve in this direction. Okay. I know, maybe I'm exaggerating, but here just to show you how to draw. It is not an actual study, just to show you the later on the cut and fill. Okay, so now just drawing the design. So enter the design level, the proposed new one. You see, look, the blue one is the design, the new elevation, the proposed elevation, where my cars will pass through without any issue, hopefully. You see, at each transition between points, of course, I have curves, as we learned in surveying or in transportation. The beginning of the curve, end of the curve, the length of the vertical curve, 150 meters. And all of these, they can be adjusted. You can adjust them. You see, depending on the space that you have. So, for example, I adjust them a bit. Here, it will change the elevation of the station. The same thing here. This is a crest curve, by the way, and this is a sag curve. You see how it is plotted? Now, the final step for the alignment is to visualize anyone. Let's see if you are still listening to me. What is the next step you think, guys? Anyone?
Cut to fill, Doctor.
Yes, sure. So it is cut and fill. We want to visualize the areas of cut and fill. So I'm gonna draw the cut and fill for you. The cut and fill, you have to press and right click, profile, view properties. We're gonna create. We go to bands. The band, you will have two bands, one for the cut, one for the fill. So this one, we double click on elevation. We choose. We start with the cut. The cut, I have to mark the labels. On the profile, it shows us between which of these two vertical alignment I want to visualize my area of cut. It is between the grid and the design. And احنا design in blue والgrid here actual condition it is colored in red. Okay, this is the first one. We add another one from the top. We call it fill data. We add fill. Okay, we have now fill data. The same thing. So between the grid and command the design vertical alignment. The system took it. Know that we have two areas, but we need to see the hash. So I press on the cut and I press on the fill. Now the system automatically will show me the areas between these two elevation, between these two vertical alignments. And that's it. Look, it's very interesting, by the way. And software, if you have the area, the surface organized very well, you have your data correctly executed. Look how beautiful this section looks. So you have, guys, this is the red. The red, this is the existing. On top here, we have the proposed. So it means here in the green, it's an area of fill or cut. Anyone? Can you hear me? Did you listen to the question?
No, Doctor, في سؤال.
Okay, this green area you see here, it's area of
Yes.
cut or fill, you think?
fill لانه البروفايل الاساسي مرسوم تحت.
صح.
يعني عم نعمل fill لنوصل للأرض.
Exactly. So guys, I think it's clear to you how we have drawn the sections. At the end, كمان the same methodology. We can go to the report and go to the profile, and you can export the cut and fill and any specific point or data needed. يعني for instance, you can export the stations of this profile, also the station of this profile. It depends on what you need to export. Hello guys, this is the first step, and actually this is half of the project. The rest of the project later on, I'm going to discuss how to create an assembly corridor and calculate the volume of cut and fill. So now we have this section here. This one you have to show me this section later on in your project. You have to draw the alignment. Once the alignment is drawn, we can draw the assembly and the corridor. One last thing, guys. Let me show you the PowerPoint. In your course, in the transportation course, you learned to collect data. For example, the design speed depending on the terrain that you have, the type of terrain, so the actual condition. Here you are working with mountainous condition, and I wrote 70, but usually it should be less. So we can choose 50, let's say, worst case scenario. One more thing, regarding these values, the side distance, these values usually are checked automatically from the Autodesk software. Remember that there's a command in the Autodesk. If they said use design criteria, automatically they will check if the K value is adequate or not, if the radius of the curve is adequate or not. So go back in your notes from the previous transportation course, and you can have all these values. These are just tables to confirm your observations. Yeah, so that's it. I'm not gonna explain further. Just to show you again the project. The project here, it is written in design speed 70. You have the given. You have to create the alignment. So now we have the alignment. I created the surface profile, proposed level, area, cut and fill. Next time I have to explain the assembly, corridor, and cross section. Please, guys, start as soon as possible. Did you install the software, anyone?
دكتور الانترنت ما بيساعد صراحه ننزل صفر.
طب طبعا الجامعه اعملوا له داونلود.
اوكي.
ما تنطروا السوفت وير كبير، يعني مسكر انا نزلته شيء 10 جيجا ما بعرف، منه مثل الاوتوديسك الاوتوكاد العادي. سو لازم تنزلوه، اوكي؟ ما تاخذوا الموضوع. مين حكي اشرف نيرفانا وزياد نزلتوا شيء السوفت وير؟
نفس المشكله دكتور الواي فاي هلا مش عم نزل.
طيب هو الموضوع يعني انا اعطيتكم قلت لكم من اسبوع نزلوا، اوكي؟ Any question?
No, Doctor.
طيب هلا this is a short example. Next time I'm going to continue the example and I'm going to try as much as I can to simplify the videos for you in order you will directly hopefully يعني execute the project and submit your report in 2 weeks, because these reports need to be corrected and then collected with the other reports. I think they have structural material, I don't know. So that's it. Any question?
No, thank you, Doctor.
Okay, yalla, see you next time. Bye bye.